we are going to discuss something very, very interesting, and that is line graphs. We're going to discuss line graphs. Line graphs. This is more like mathematics, but remember I had told us in previous classes that you cannot do chemistry effectively without understanding basic mathematics. Do you know that mathematics is everywhere around chemistry laboratory? That you can carry out experiments in a laboratory, and then you're expected that the data you obtain, you feed them into line graphs and obtain certain parameters. Like for example, you can fit in data and obtain parameters like enthalpy of reaction, like entropy of reaction, like Gibbs rate energy of reaction, even activation energy, and a whole lot of them. How do you fit this into a straight line graph? How do you interpret the graph? How do you obtain these very parameters from the graph? It is what we want to do today. Now, interestingly, for every graph, there is an observed variable and there is a control variable. Now, to explain that, let us look at something. Now, if you have a graph of this nature, let's say you have a graph of this nature, you have a graph of this nature, now you have a line across, okay. Let's say you have a graph of this nature, this and this. This graph is explained as y equals to mx plus c. Now, what it means is that the straight line graph, the straight line itself, is explained as y equals to mx plus c, where of course this is the straight line equation. Okay, for this particular graph, the y that you see there is the observed parameter or variable. So it means that from this part of your graph, if this was your sheet, from this part of your graph, if this was your sheet, it implies that this side of your graph is the observed variable. Is the observed variable, and that is usually y, the observed variable, and this side is the controlled variable, and this is usually your x. So this side of the graph is always positive, and this side of the graph is always negative. This side of the graph is always positive and this side is always negative. Now it means that your y, which is the observed variable, is that variable that can be measured. The observed variable is a variable that can be measured, while the control variable is the variable that cannot be measured but can be varied. The values can be varied. So for every graph you have, the x part of the graph can be varied, while the y part is the one you can measure. Now, your m that we have here define what you call the slope, or you call it the gradient. Now, the slope or the gradient simply explain the steepness of the line, the steepness of this plot. And usually it's a very important factor because it is what you use to determine those parameters I had mentioned earlier, as activation energy, as enthalpies, entropies. Now, it's usually being defined as m is equals to change in y all over change in x, which means that it is defined as the difference in the observed variable to the difference in the control variable. And it is always being obtained from what we call a triangular diagram, or you could call it a tangent that is drawn. But since we already have a tangent, we could just put a triangle at any point you put a triangle at any point here. You just put a triangle at any point which you wish to. Once you put a triangle at any point you wish to, this side is the change in y and this side is the change in x. That means this defines what you call the slope, or you call your gradient. Now the c is what you define as the intercept. Usually the intercept is a line, the point at which the line cuts the y-axis. The point at which the line cuts the y-axis is the intercept, which is c. And now, if it is a point at which the line cuts the y-axis, it simply means that the intercept is the same thing as the y, which is the observed variable, at point 0 of the control variable. That means at this point where x is 0, this point where y, the line cut y, where x is 0, is your intercept, which is what? Is your intercept, which is what? Your c. Is your intercept, which is what? Your c. That means y being equals to x at 0 is equals to c. That is the beauty of the graphical work. So you can see that there are 1, 2, 3, 4 parameters in a straight line graph. And the first parameter is the observed variable y, which is the variable that is measured. And then you have the m, which is the slope or the gradient, obtained from what? The quotient of what? The change, the difference in y, observed variable, and the difference in x, which is a control variable. And then you have x, where your x is what? The control variable itself, which is a variable that is not measured but can be varied. And then you have the c, which is your intercept, where the line cuts the y-axis at point 0. Now that is the explanation to a straight line graph. If you needed to fit in data you obtained from your laboratory work to obtain a straight line graph, for you to be able to get these parameters, especially the slope. Now we are going to take a question to clarify the point that we just made here. Let's assume we have a question. Now we are going to put this off to attempt that question. Okay, assuming we are given a graph already, and then we are expected to look for the equation for that particular graph. Those are very common questions, even in mathematics questions in WAEC and all those things. But in chemistry, we can also apply them. So supposing we're given a question, let us say we're given this kind of a plot. We're given this kind of a plot. We're given this plot, and we're given this plot in this way. Okay, we're given this plot in this way, and of course we know that this is our x-axis and this is our y-axis. Of course we have defined those things already, that this is a control variable that can be varied, and this is the observed variable that is measurable. Now this side we said is the positive side, and we have plus 1, plus 2, plus 3, okay, and 4. And here we have and here we also have minus 3, minus 2, minus 1. And here we have, let's have this. This is 3, 2, 1. This of course is 0 at this point. And here we have minus 1, minus 2, minus 3. Let's say we're given a graph that it cuts at this point. Let's say we're given a graph that cuts at this point. The line cuts at this point. Okay. The line cuts at this point. Now the question is, for y equals to mx plus c, what is this represent? What is the question? What is the line graph? What is the equation? This equation, what is the physical equation for this particular graph that is being plotted? Now, to understand this, our y, remember that our y is simply the observed variable that can be measured. Is it not so? Okay. So our m is a slope. So we're going to look for the slope. So for us to look for the slope, we are going to cast our minds back again to the first diagram we had, which tells us that the slope is simply defined as m equals to what? The change in y over the change in x. So by doing that, it means we are going to draw a triangle across this board. Now, at any point where you wish to, just put up a triangle. Let's put up a triangle here that probably terminates, let's say it terminates at the point, okay, let's say it terminates at this point in order to get the slope, which is the gradient. If you take a look at this, this is 3, and this line is falling at 0.5. This minus 1, this minus 0.5, okay? And then this is falling at, let's say, about 2.2 or thereabout, or you can take it at 2.5, and then this also falling here. Now, if this is our change in y and this is our change in x, that means that following what we have here, the change in y is going to be what? 3 minus, this is 0.5. 0.5. Okay, all over the change in x is going to be what? It's going to be this. This is about, let's take it to 1.5. 1.5 minus 0.5. Now, this is because even at this point it falls at 0.5 for both the y and the x. Okay, so with this, we can possibly say 3 minus 0.5. Of course, minus is plus. So 3 plus 0.5 will give us 3.5. So we have 3.5 all over. 1 plus 1.5 minus is plus, so we have 2. We have 2.0. That means that our m will be equals to what? It's going to be what? 3.5 divided by what? 2.0. So give us about 1 point something. So give us 1, and we have 1.5 remaining. So let us say approximately what we have is 1. Let's say approximately we have 1.0, because we are going to have 1 point some numbers when you divide this by this. Now, if our m is that means that is our slope. And then our c, remember that our c is defined as the intercept, a point where the line cuts what? The y-axis at 0. Now, if this is 0, this straight line cuts at plus 1. So it means that the intercept here, the intercept is also here, which is what? C is what? 1. And if C is 1, then our equation y is equals to mx plus c can be written as what? Y is equals to m, which is 1, remaining plus x, let's say 1x plus 1. This is the representation. That means this equation in this line is y equals to 1x plus 1. So you can just say y, you can still write it as y equals to x plus 1. So it's the same thing like that. So you can see that you are able to get the equation of this straight line from this work that you've seen here. Now, if you were rather working on a data in the lab and you are expected to get maybe activation energy, that means that the slope which you have solved and gotten here will be your activation energy. And then the intercept is there that will explain another kind of result for you. Now, I hope that with what we have done today, relating the line graphs to some work in a laboratory has made sense to you. In our subsequent class, we are going to be discussing something beautiful again that is mathematical in nature related to chemistry. Do not forget to subscribe. Do not forget to also like. Do not forget to go to my Facebook page and follow.